Okay, everyone, I think that we're good to go. Today we have a really interesting topic. This is the XAF community stand-up of October. And what we're going to talk about today is how to integrate search methods or search options on your application. In general, in .NET application, but in this case, we are talking about XAF. Javier won't be joining us today, at least for the first part of the stand-up. So if there are some announcements, he will do them in the end. But for the time being, I will start with the examples because we have a kind of a little bit to see. So, well, I guess everyone knows me. Jorge Ojeda, I'm the Express MVP, and I work for Sari and Bit Frameworks. And today I'm the only one who is joining from the MVPs here. So I will be the only one on the show. Okay, so the topic of today is integrating full text search into XAF applications. In here, we will do like some part that is conceptual and some part that will be technical. The conceptual part will be like kind of small because we don't need to explain too much what this is. But the idea is this. This will be the agenda for today. First, we will explain what is full text search, what are the benefits of using full text search, and how can we implement it using different engines, because full text search is more like a general concept that can be implemented in different ways using different technologies. So in this case, we're going to see two examples, one using Apache Elasticsearch and the other one using Postgres. So let's start with the main concept. What is Elasticsearch, or what is a full text search in general? I guess everyone had this problem before. Is, okay, I need to search in my database, but I don't know where the stuff are, which means that you need to search against either one column if you know where the values are, or you need to search against several columns. So those type of queries can be really resource consuming and slow, especially if you have to run it through several different tables. So the idea behind full text search is, here I have this index. This index contains everything that I need, and then I will query the index. And the index lives in a different database, or actually in a different server or engine than your data itself. So the idea is to put something on top of your database to search first, and then once you have the results, show them to the user, and then from that, just query the exact record that you need to retrieve. This technique is really used for, is wide use in e-commerce and also in activity stream, which are basically social networks. When you want to search for a post, you search, and whatever you type will be searching all the possible fields and all the possible objects also. So what are the characteristics of, the key characteristics of using full text search? Let's see. First is indexing. You have a separate index for your objects and your values that is not your relational database. So the idea is that the indexing process can be heavy and can take time and a lot of resources. So if you're indexing your table, you may be indexing for some specific use case, but for search is a different use case. So you might need to index in a different way. So it's better to basically outsource that problem to a different engine, in this case, a search engine like Apache. So the second thing that is really a key characteristic is ranking. Sometimes, and most of the time, you don't know what you're exactly looking for. What you're trying to do is put some part of a word or some key parts of a sentence, and you try to come up with what you can find that is related to these search terms. So in full text search, you have the concept of ranking, and that is widely used in search engines like Google. For example, when you type XAF or Developer Express or SARI, it just doesn't show the results that contains that word. It ranks the result in some specific way, depending on how they are evaluating how much each search term is worthy on the search. So this is like basically giving context to the search terms, thinking, for example, the word run in English. It can be in a sentence as running. So you also need to have the concept of which language are you querying to know how the query terms can be different if they're used in different time, in different sentences, different first person, second person, third person. And that will give it like a ranking, like how close is to what I'm looking for. So that's a really interesting concept. The next concept is that you have like advanced search capabilities. In most of the search, the Elasticsearch type of engines or full text search engines, you can use mostly all the operators that you can use in a normal query. So you can say not, for example, you can use wildcards like asterisk. You can search for partial results or for complete results. And also, depending on the engine that you're using, you can do proximity searches, which is, for example, you can see that in Facebook. And I wanted to create an example using their search engine, but I just didn't have enough time. A proximity search you can search something like, okay, you have item A, which is a product, and then you have item D, which is a different product. And in the network of nodes of all the possible relationship between products, you want to see how close is one to the other. That in Facebook specifically is used to tell you, okay, these are the people that you might know. So it's a proximity search. So it's kind of a really interesting topic. And then you have, well, this both should be just one item. Just there was a problem in the presentation, but you can use natural language processing, which basically means that you're able to use to query as you will asking a person, something like what you do with ChatGPT. You don't write code to ask questions to ChatGPT, or you don't add code to Google, for example. You don't write like not or operators. You can use them if you want them, but it's not necessary to do that. So just let's see while we're in the presentation. Okay, everyone is in. So these are the main concept of full text search. So first, I'm going to present a problem, which is a prototype that we did before in the past, and that a lot of people like it, using XAF and some modified version of how XAF search between the objects. So for that, let me stop the presentation for a little bit. And we're going to Visual Studio. So let's see, we have this one. Yeah, let's put this here. And can someone tell me if you're seeing the studio? That's the screen that you're seeing. If someone can write it in the chat, will be really nice. Because I don't see the highlight anymore, so I don't know if I'm sharing. Okay, thank you. So, okay, this is one of the examples that we show in the past. We have different versions of this one. We call it universal search. And the idea in this is that we're replacing the search capabilities of XAF. So what we did is this trick. For example, let's say that you want to search something across your whole system. So the idea here was, okay, how can we tell which objects are searchable? So as always, we came up with an attribute. So the attribute that we have here is, we call it universal search. And it receives two parameters. First, which are the properties that you want to display once you find this object, or once there is a match. And also, how can you format them? How do you want to format the match? For example, invoice number something, name and country. It will depend on the object, how you want to match, how you want to format the results that you're doing on each match. So basically, what we have here is that we register the types, the persistent objects, and we tell it, okay, if it has this attribute, then you can search over it. So in this case, I have it over city and over products. And you see that the formatting is different. So in customer, I just put it for doing a test before, to test the examples that we want to show. And then I comment it out so I can show you the effect. So here there's only like one controller, and I'm going to just explain you a little bit the controller. I'm not going to go into details on how it works, but basically it goes like this. Once you hit search, that you will see here. What we do is basically we search for all the possible types that are decorated with the universal search attribute. Then from that one, we get what we want to display. And then what we do is we create a data view. And basically, what we're doing is building a query out of the properties that we can search on each of the objects. And after that, what we do is we execute that query, we get some information from XAF, and then we build the results. This is kind of really nice in the end because, to be honest, I love it. But the problem is that if you have 100 objects decorated with the universal search attribute, then you will do 100 queries. So, and you will be hitting your production database at that moment. So that can be not efficient. So the idea that we have was to replace how we do the search. Everything else was fine. Just let me show you how this works, because it's also really interesting to see. And if you have any questions, you can type it in the chat. And once we go to that moment, to the question parts, we will review them. Especially when Javier joins to the meeting. Okay, let's wait for this to build up. For some reason, once I'm sharing the screen with Zoom, it doesn't matter which computer you have, everything becomes really, really, really slow. Okay, so let's put this one in here. And then the other one should be the studio, but which studio? I don't even see it there. Okay, let's just use this one here. What I want to show you is actually the query that is going to be executed. So let's log in as admin. The user is not, I mean, this is not the important part. The important part is the search. So let's wait for this to run. Okay, so here we have a few entities. Let's go and check. We have products. It's basically food, all the food that I love, and cities. These are the objects that are marked as with the universal search attribute. And also we have customers. We have Jaime, which his address is just Italy. So if I go to the universal search section, and let's see the output here. So if I clear this and I search for ITA, like Italy, you see that we got 3 matches. We had one match that is the city of Rome and 2 different products. One is pizza, one is spaghetti, which in description has the word Italian. So this will match. But let's see what happened in the database level. So this is where the action started to execute. Now I can make this longer. And then we did basically 2 different queries. So here is the operator that I created. And then we have the execution, then we collect the records, and then since we're looping through all the possible entities that are decorated with that attribute, you will see this several times in the output. Here is again. It's for a different entity. So basically, we executed 2 queries, and that's how we got these results. And then the beautiful thing about this prototype was that if I want to go to this detail view, it's a city. I go here, and then I go to the correct record, like this is a city. And, oh, well, let's search again. And if we want a product, then here we have a product detail view. And just to show something, if we want to include one more entity, let's do it with customer. Now, when we run it, it will also search in customers. So you can see that it's doing the matching per entity, but that means each object that you have, each entity will be plus one more query. So if you have a big database, maybe this is not a good idea. But some of the people who was using this prototype, they decorated all the entities, then this started to be really, really slow. So that is when we need to come up with a different solution. So we're going to present that. It's exactly the same prototype. It's not this exact solution, but it's the same prototype. We copied and we did a different implementation. So let's see. So let's make this smaller. Okay, now if we go to universal search here, and we clear this part, Let's do the same. Now also there is a customer here in my results, Jaime. And as you can see, here is like 1, 2, 3 times. Basically, we executed 3 queries. And here you can see what was the criteria operator for this case. So thinking about this is the part that we kind of wanted to replace, how we execute the query. Everything else was fine, like how we present the results and how we open the correct detail view. That's kind of, there is a lot of tutorials about that in Developer Express documentation, but we wanted to make this faster and better. So it's time for PowerPoint again. So what we decided to include, let's see. What we decided to include was to see how Apache Elasticsearch will do it, or full text search. Usually, I mean, those terms are interchangeable one to another, but some are easy to pronounce if you speak Spanish, some are not. Okay, so the idea here was, okay, Apache create this Elasticsearch server, which is based on Apache Lucene library. So the idea is that this is like kind of a memory database that is indexing all the time. So it creates a specific index that uses the advantages that I showed before, like it understands which language you're using to query. And by language, I mean if it's in English, Spanish, Italian, Russian, whatever. Give the context to the search query and then execute it. So we choose Apache Elasticsearch because it's kind of the most common search indexing servers out there. And it's free, of course, that's good. You can host it yourself in a Linux machine, or you can, they offer a service, there is a hosted service. But if you want to do it yourself, you can use a Contabo server, just install Apache Elasticsearch, or if you're using Windows, it's just one click to run it. And then you have the search server. And the flow that this does is something like this. You have your users, they have a specific UI for searching. Then you build a query with this query you execute it on the Elasticsearch server. And you can go both ways depending on what your flow is. You can, from the results that you have here, go and do that specific query also in the database. So once you present that results to the user, you don't have to do one more trip to the server to pull the data itself. We have seen different implementations of this. One is that you get the results, you send the results back to the users, and once the user click on the result, then you go back and open the record. That seems longer depending on your infrastructure, or you can, from the search result, you can already start catching the real results from the database. So this is what we're going to do. Now on XAF. So let's close this one. We don't need it anymore. And let's see the next implementation. The next implementation is actually here. It's the same solution, but it's renamed and with some specific things modified. So let me walk you through what we did here. First, what are we using? If you want to see how an Apache Elasticsearch server looks like, it looks like this. Basically, it's a console process. And to run it is self-contained. You just have to, let's see, where is this window? Here. You just have to run this bat file. It will depend also if you host it yourself, if you host it in Linux, maybe the process is different, but it's mostly like super simple. Before you start doing the specific optimizations, because you can optimize this in several different ways. So I'm using just the default implementation. And from that, you only just need to run the server. And after that, you just need, here's the password for the server. And here is the certificate. You need both values to be able to connect to the server. So in the XAF side, what we added was a service. And I see something strange here. Some namings are strange, but well, let's hope that it's wrong and it's not modified by any strange thing. Okay, so basically we have this extension, which includes, this will add a service, and the service will create something that I call the generic model in this case. So the generic model is the model that you're using to create the indexes. So here is kind of a first type of decision that you need to make on your implementation is, do I have a specific structure for my index, or can I use general structures? Like, for example, in here, we created this one that is general purpose, that we just add some information that that is important for us for the process, and everything else is stored in the keywords. So if you're using something more specific, maybe your index model will look more like your entity that you want to index. Sometimes it's one-to-one. Sometimes is a simplified version. It depends. But in this case, we're using this generic model because we are only interested in a few things. The type, the key, because with these two values, we can refer, we can find the object inside stuff. We know the object type and we know the object key. You can do object space, get by key, or find whatever you want. And the keywords is the information that we're saving from the object in order to search for it. So basically this extension, we just have one call here that is add Elasticsearch. So if we go and see it in the startup, you just add a service and that's it. Nothing big there. And there are some values that we need to replace right now. We need to replace the password because it's a brand new server. Because the other ones that I had, they were full of indexes, of wrong indexes from all the tests that I was doing. So now we have a brand new server. Okay, so those are the values that we need to modify. And beside that, this service here, this Elasticsearch service, is a web API. And the web API, you can just send some requests. So in here, for example, the only configuration that we're saving is in the URL of where the service is running and which model do we want to search once we do a search. In this case, where this will be the default index we want to search. You can have several indexes. You can have one index with some specific information and another one with a different set of properties, depending on your use case. The more that you have, the better. So, but in this case, we're using only one. So after that, the idea is exactly the same, is we need to create records and we need to index those records. So for that, what I'm going to do, I'm just going to replace, this one is going to be 5. And just in case, also for our next demo, I will also change the connection string so it doesn't explode. So this one will be, let's just put a number 3. Okay. So let's run this and let's wait a little bit because it will take some time. And in the meantime, if there is any question, feel free to write it in the chat. And while this is compiling and creating the databases, I can answer the questions. Also, the way that I'm creating the indexes at the moment, you can do it in different ways depending on how you access your data and how you create the data in the application. For example, I did this, I got this modification controller. And if the objects implements this interface, with this, I get the information to create the index. So basically, I'm using the modification controller to know that every time that we save, we should create an index and send it to the server for it to index it, actually. And we kind of just need to know if it's a new object or if the object was there before, because we need to know what we need to do on the server side. If we need to re-index one record that was already there, or just create a new entry. So, and also you can just override your save of your persistent object or your entity framework object, and then create the index there. It's basically up to you. And here we have some another controller which basically creates sample information and do the indexing. So this one will create the cities, products, and customers, and then index all of them. So let's see. Yes, we're here. So let's wait for this to run. And what I want to show is that the concept is exactly the same. It uses all the parts of the universal search. The difference is that to search, it doesn't hit the database. It just go to the Apache server, get the indexes, and then once we click the record, then we read the actual record. So these searches are super light on the application because they don't run inside of the application or inside of the database. So let's do first the Elasticsearch, but we need, I think there is nothing right now here. Well, we have the users, there is no blogs, no cities, no customers. So create sample data. And now is creating the records and index, sending to the Apache server. So we did create some indexes already. So now we have different versions of this. We had the universal search from before, which we are not going to use right now, but we have the Elasticsearch. So let's see, this is the one that is running. Let's see the output. Let's clear all of these. Well, let's check something first. Let's say, well, let's do the same example with Italy. So let's go to the Elasticsearch. And I have not touched this demo for like a few days. I prepared it for last week, thinking that the meetup was last week. So I hope that everything works. You know how when you're doing a live demo, what happens. So let's see. Let's clear this, and here. What I want to show you is that there should be no search. See? These queries are actually to query the permissions for the action and to see which user is executing the action and things like that. This is basically security system, but there is no actual query to the records. We didn't go to the database itself, but we do have results. So we have a city, we have a customer, we have two different products, both of them with Italy or it in the name. And once we let's clear this. Once we click on the record, we will actually do a query to a database. I mean, to the actual XAF database. So then we have all these other queries, right? And what we're trying to avoid is just to avoid those extra queries. So as you can see, you can perform search, and then once you find what you want, then open that record. Why to hit the database all the time that you're opening a list view with records that you will actually not use in the end? So as you can see, it's like super simple to integrate the Elasticsearch. You just need to create the indexes once you're saving, save some keywords from your object, and then to just query the object is also really simple. So let me show you the method that do that. So basically the method is this one. We get the query term, and then we create a query, and then we set the max size if we want to have just 5,000 results. And the thing is that this will not use any memory from your SAF application, will not use that database also. So you can keep searching until you find the record that you want, and then just click and open the detailed view for that record, which I think is the way to go. I will replace all the list views with this. Also, you can use the Apache Elasticsearch server to produce some type of in-memory datasets if you want to create queries for reports, or for like, if you're using the pivot, the dicing and the slicing, that can be kind of heavy. So you can also use the Elasticsearch server for that. The idea behind the Elasticsearch server is not the search part, actually, is that it's an in-memory database. Most of the results are held in memory, so those type of servers use a lot of RAM in general. But RAM is kind of really cheap in virtual machines right now, in virtual private servers. For 50 euros, you can have something that is 64 gigabytes of RAM that will be bigger than most people databases. You can put everything on Apache Elasticsearch server, and you will be able to index it and access it really, really quick. This is what we have for the Elasticsearch, but there are many ways to do an Elasticsearch. So now we're going back to the PowerPoint for just a few more slices. So let's see. Right. And I don't know why I always go to the beginning. I should start where I was. So we are here, right? So the next way that we're going to, the next way that we're going to implement the Elasticsearch will be using Postgres. As everyone knows, I love Postgres. It's one of my favorite databases. It's basically Oracle without the price tag. And even though lately I've been becoming more like an Microsoft SQL Server person just because it works and it's in Azure. Postgres is still, if I want to do an open source implementation of something, it will be Apache and Postgres, and of course .NET in the backend. So this is basically something really like Elasticsearch, but with some different things that you can do in general. In the case of Postgres, what we are searching is stored in vectors. So whatever text that you are saving is, you need to save it also in a different type of column that are vector columns. And those columns can have a specific type of indexes depending on how you want to search. So the characteristic of Postgres full text search are almost the same as the one in Apache. They both do the same kind of things. Some things looks more simple in Postgres. Some things look more simple on Apache. So it's up to you to decide which implementation you want to run. I think I will go for the one of Apache for one reason. The one in Apache is using a memory database that you can eventually persist to the disk. In Postgres, the data is saved on the disk. So even though vector search are really fast, they still have the I/O problem that you're using a physical disk to read the information. So in this case, I will go for Apache, even though I like Postgres the most. So the first thing that Postgres offers us is tokenization, which means from the keywords that we want to save, it make it tokens and give them some specific numeric value. So vector search, they do work different on each implementation. So the one from Postgres is specifically for Postgres. The tokens for Postgres are also specific to Postgres. But there is different other engines that do tokenization, and then you can do search over these tokens. You can see that also if you use ChatGPT, or if you have used the example from, there is one XAFer in the community who did a SAF application that connects to ChatGPT. Then you have the concept of tokens. And also in all the vectors databases, you have the concept of tokens, which is how the information is stored in there. So the next key characteristic is language awareness. And this means that you can pass the search terms and tell, okay, these search terms are in Spanish, or these search terms are in English. And depending on which language you are and how the search terms are split on each result, you can get rankings also or weights on the results, telling like, okay, this is rank 0 from your searches. So that means that it's closer to what you want to get. Or you can say something like, these documents from a specific table are more important than from table A are more important than from table B. So it means that the ranking will be different depending on which table the records are. So that's why you use this concept of weighting. You can tell, okay, this search should be 80% on this side and 20% of this side. You tell it like which index you want to give more value to, and that will affect eventually the ranking. The search operators, we had this before. I mean, we have them also in Apache. You can say something like not this. Also, some really nice thing about language awareness is that you're not looking to match a specific part of sentences. For example, in Spanish, articles are male or female depending on the word. So if we use a query that is on Elasticsearch, specifically in Postgres, since you have to tell on which language the results are going to come or which language are you searching for, you can tell, okay, those little words like articles, you can ignore them because they are not useful for the search. So it's not a word-to-word matching. It's more like natural language, like what ChatGPT uses. And all this idea came from implementing ChatGPT with XAF, that you need the concept of tokenization. And sometimes you want to save the searches that you did before or the queries that you did before. Because if you do something like it's a lot like that, like 90% the same, you don't go again to the server. You just retrieve the local results. So, well, we were talking about this before, ranking, depending what you're looking for and where the words are placed on the different fields that you're using, and the different weights that you put to each field, the ranking will be different on the results. So this is super important for search engine type of implementations. Also, you can, this one also is a little bit different than Apache, is that in Postgres, you have different type of columns. The most common ones are text. You will run this over text columns, but you can also use JSON columns or binary JSON columns, and the indexing will still work. So this is kind of something really specific of Postgres, but I think that you can do something alike on Apache. In Apache, everything is like as a document. Basically, it's a JSON already. But I don't know if you support JSON within a JSON. So in that side is like one more point for Postgres. And well, the last key characteristic is this also a little bit different from Apache, is that the type of indexes that you're using. You have two types of indexes, which are gene and hist. If you're using a small amount of data, gene is faster. And if you're using large amount of data, gist is faster. And they just refer like that in the documentation. So there is no much explanation how it works. This also, one of the kind of problem of Elasticsearch is that it's a little bit magical. It's non-deterministic, depending on your settings that you have for your server and what are you saving, you might get different results all the time. So it's not like a query that is exact. That's why it's not exact query. It's basically like, this is the results. This is the most, this is more likely to what you're looking for. So it's up to you to decide what, which result is more valid. Okay, so then let's check the implementation for this one. So this one is a little bit different. Actually, this one uses entity framework. So the idea here was kind of the same. So what we did is we added another extension, and the extension just create the DB context. So in this case, we're using XPO and entity framework just to run over entity framework the full text search. So if we go to the definition of the context, basically it's a normal Postgres database with some specific things. These options are for using the geotypes. For example, to search in a map, to search latitude and longitude, like give me these points if they are 5 kilometers close to this other point. So this is supposed to only add those types for geolocation, but it also add the other types for Postgres. So the vectors that you use for full text search. So since in Entity Framework, we have kind of full control on the on model creating, on how the properties are getting created. In here, we are telling it that we're creating a vector in English for this table, for this column, and the weight. Being A, the top weight, I mean, the most important for the indexing, then B and C. This will affect how your results are ranked. So it's up to you to decide what is more important for your specific use case. So, okay. This is everything that we need in this side. And to show you the control, let's go here to the sample data. And we have this, we have a simple action to create vectors. So let's see it. It's kind of really simple. We create some articles, some blog articles. And in here, I added some notes to know which one is going to return first, depending on which search term we use. So see, this is basically a normal persistent object. And what we do in the end, we go to this function, create vector. And we have, this is one of the cases where the index object is almost the same as the object that we're searching. In this case, it's actually exactly the same. So we're saving in the vector database, which is Postgres, and we're searching on, and we're saving also on the SQL Server database. So in here, we created the articles, and that's basically it, nothing more. And then we have the search implementation, which is a little bit different than the other one. All the mechanics of showing the results is the same, and opening the right record is also the same. But what it changed is how the search is executed. So let's see, it's here. So this is the query in Entity Framework Core using Postgres that will do the full text search. So the search terms that we're going to pass, if you can see, we don't use a like query. We tell it, okay, we have a vector, and the vector should use a specific function, and then we pass the search term. And then also for the sorting, you tell it, okay, use this vector. And with the vector, use the ranking based on the function tsquery using this term. So it's kind of a really specific implementation. The SQL for this is kind of really big. That's why I did it with the framework. You can use this just only in a query, like basically a text. And I think in here you can see how these functions are registered. Here you have all these different vectors functions. So you can see how they are, being added to the Postgres engine. So, okay, let's run this one. Let's open the databases also so you can see the vectors, how they look like. Let's see. Well, in the meantime, while this opens, let me show you the database. So this was the one that I was using before to test. And if we check the schemas, then tables, then we have, you get these special references. I think that happens when you add the special types for Postgres. But if we want to check the columns, see, we have everything that we define in the object plus the vector column, which is computed. So this vector is computed out of the values of title, subtitle, and content. If we view data here, here is the output. And these are basically text columns, nothing special in there. And these are the vectors. See, for the vectors, each part of a word of a text is represented by a token. So then it's kind of semi-human readable, but the numbers mean something, like which part of the vector is and how much weight it has also on the indexing. So the good thing about this one is that you kind of see a little bit of what's happening underneath the search. So let's go here. And you will see that it's the same idea, that we do the search, we don't hit the database at all. And once we click the record, then we actually go to the database. So let's see, we don't have any blocks. So let's create sample vectors. And now we have some information here. Okay, so we have these blocks. And as I show you, basically in the context that we have weighted the columns differently. So A, B, and C, being A the most valuable for the search and C the less valuable for the search. So let's go here and then let's do the search. So post vector search. So in here, if we use the term, let's go and check in the blocks. I think we can use jungle because jungle is in several. Yes. And okay, here we have the values. And as you can see, this kind of a really complicated query. Okay, this part here is XAF. As the same that we saw before when we execute any of the actions. You check the security system to see if the user has permission to execute the action. But after this is the entity framework part, executing the full text search. So see what it's doing in general, and then the generated expression. So it can be a little bit complicated to write this type of queries. And it's just showing because I set the context to show the information. on the console, so you can see the different queries. But so far, again, we have not hit our normal database. And the difference between this and the one with Apache Elasticsearch is that we do have ranking here. So since the word jungle is in the title and title is the highest weight on the search, this one is 0. See, this one is the same. It has the word jungle in the title, but it's in the end of the sentence. And that's why the ranking is different from the first one, because in the first one, the word jungle appears first. So in the order where the words or the search terms are appearing, will change the weighting on the ranking. So let's do a different search. For example, I think adventure. So see, the first one, since adventure, it's not actually the word adventure, but it's adventurous. So that's why the language is so important when you do the search and when you do the index for the search. The index should have language because from one of since this is language aware, basically, what will happen is that it understands that adventurous, that word comes from adventure. So that's why it matches, even though it's not the same word and it's not 100% match. And we're not using like operator at the moment. And that's why it makes it the first result. So basically, in general, kind of these are the implementations that we have. And for you to improve on them, basically what you need to understand is if it's language awareness your search, how you will weight the columns on tell, okay, this is more valuable than this, or the objects inside of the search, and which type of indexes you want to have. If you're using posters, you know that one is better for a small amount of data, one is better for big amount of data. And also you can have several indexes. In this case, we're showing only one per implementation, one in Postgres and one in Apache. But it usually, you can have several indexes. For example, you can index the same information in Spanish or English or whatever, depending on the language that you're using, and then search in a specific language, because your search results will be really different if you use the wrong language set for the search or for the index. And well, that's basically everything that we have for today. So here is the thank you slides. And if you have any questions, we still have some time. So feel free to write it in the chat, or if not, if the question doesn't come up today, you can send me an email or contact us in the group. I think that this repository is open source. If not, I will publish it on GitHub and then put the link on the Facebook group. And let's see if there are like questions in the chat. I cannot see the chat bar, so okay. So it looks like there are no questions. So everything was as clear as water. But well, still we have let's give it one more minute just in case someone has any questions. And well, if not, you can just download the repo and take a look to it. It's kind of really, really simple. And I was surprised how simple it is to do this integration. Most of the code that we got was the original implementation of the universal search, which was to present the results, which are non-persistent, and then to point the list view to the right record. And after that, we just replacing searching underneath. And so ended up being really simple, but really interesting experiment. The first experiment that we did with Postgres, we kind of needed to know which information we had. We put a sample, because if not, the ranking, we could not calculate how the ranking was going to happen. For this ranking that I showed you, we practiced it before and we knew how it was and why it was like that. So it will take you a little time to tweak your search engine that you use, and you will have to spend more time doing those tweakings than basically executing the code that, as you can see, is kind of really simple. But well, it seems that that's everything for today. So if you have any questions, feel free to write it in the Facebook group, and I will post this repo later. Thanks, Stanislav. So, well, let's see you guys on the next community stand-up. Take care. Bye-bye.